So it's the top of the hour, and I want to welcome everybody. Welcome to the 2021 Sea Ice Outlook Post-Season Review and Discussion, which is hosted by the Sea Ice Prediction Network Phase 2, also known as SIPN2. It's facilitated today by the Arctic Research Consortium of the United States, or ARCUS. Today's support team includes Stacy Stout, Kubajenda, and me, Betsy Turner-Bogren. Today, October 11th, is recognized as Indigenous Peoples Day. I live and work in interior Alaska on land that I acknowledge as the traditional homelands of the Lower Dene people. Today's webinar will provide a post-season review and discussion of the 2021 Sea Ice Outlook, or SIO, and lessons learned. We will have 3 10-minute presentations from members of the SIPN2 leadership team, and those will include an overview of observed conditions during the 2021 Arctic Sea Ice Retreat season, presented by Walt Meier, a summary of skill of the 2021 Sea Ice Outlook probability and extent forecasts across models, presented by Edward Blanchard-Wrigglesworth, and finally an overview of lessons learned from the 2021 SIO and the SIPN2 project, presented by Uma Bhatt. There'll be 20 minutes for open discussion following each of the presentations. Today's webinar is being recorded. It will be archived and available online, and you'll receive an email when that archive is available. A link to an online survey will be available at the end of today's webinar. We appreciate any feedback you could give. Before our presentation begins, I will share a quick review of how to navigate Zoom. I know most of you are familiar with this, but we'll just make sure everybody's on the same page. Your Zoom controls, video, mic, chat, etc. can be found by hovering your mouse over the bottom of your Zoom window. You can view this webinar in gallery view, next slide please, or speaker view. The gallery view allows you to see the webcams of other online participants. Speaker view allows you to only see the view of the presenter's webcam and presentations. To switch back and forth, you use the button in the upper right-hand corner. You are encouraged to chat with other participants or everyone at any time during the presentation. To do so, click the chat icon at the bottom of the screen and select the name of the participant with whom you wish to chat. There's also an option to chat with everyone. Next slide. When you entered the meeting, your video was switched off and your audio was muted by the host. You may turn on your video or mic at any time. However, we do ask that you please keep your microphone muted when you are not speaking, and this will help prevent disruptions and background noise during the presentations. If you're joining the meeting by phone, you can unmute and mute yourself by pressing *6. Next slide. There will be 20 minutes for questions and discussions following each of the presentations. If you're joining by Zoom, you may type your questions or discussion into the chat window at any time. I'll track them and read them aloud following each of the presentations. Or you can raise your hand to indicate that you want to speak. If you're joining by phone, you will need to raise your hand by pressing *9 and unmute yourself by pressing *6 to ask questions aloud. I'll remind you of this at the start of the 20-minute question and discussion session. For any technical problems today, please contact our support staff, Stacy Stout or Kubajenda, via chat or email. At email, it's Stacy, S-T-A-C-E-Y, @arcus.org, that's A-R-C-U-S, or Kuba, K-U-B-A, @arcus.org. Next slide, please. The 2021 Sea Ice Outlook Postseason Review and Discussion is organized by members of the SIPN2 leadership team. It's presented today in lieu of a published interim Sea Ice Outlook postseason report. Today's event will be recorded, as I said, archived, and on the SIPN2 website. We will notify the community when it is available. So I'd like to start our program today. Our first speaker is Walt Meier, and he will provide an overview of observed conditions during the 2021 Arctic Sea Ice Retreat season. Walt Meier is a senior research scientist at the National Snow and Ice Data Center, or NSIDC, and he specializes in sea ice, passive microwave, remote sensing, Arctic climate change, and climate change. Walt, I'll turn the control over to you now.
Okay, thank you, Betsy. Let me share my screen here. All right, folks can see that. Okay, so thanks, Betsy. I will quickly go through a very short and very quick recap of the summer melt season and what happened to the ice, and then open it up for discussion and questions. So if I go through something too quick, we can certainly revisit that, but I want to try to at least touch on kind of the major things. I think one of the first is, as a precursor, we had a pretty unusual, really somewhat unusual circulation pattern going back into January and February. It was dominated by high pressure, particularly strong in February, and it was a little bit shifted off of what the typical Beaufort high is. It was shifted to the west, more over the Siberian side, over like the East Siberian Sea area, and that led to circulation of the ice that, instead of being more kind of parallel to the coastline in the Beaufort Sea, was more onshore. So there was a lot of onshore motion during the winter towards the Alaskan and Canadian northern coastline. And that, that brought a lot of convergence on the coast, and then an infiltration of multi-year ice, which you can see here in the Ice Age product. This is January, the beginning of the year, and actually it goes back to December. There was already an influx of ice, but if you compare January towards March, you can see that ice moved into the Beaufort and Chukchi Sea region between there. And so you had kind of this preconditioning in the Beaufort Sea with more multi-year ice, probably more thicker ice than what we had seen in some of the more recent years. The next thing that kind of stuck out was warm temperatures over the Laptev East Siberian area, which led to early melt onset particularly in the Laptev Sea. And that resulted in an early opening and early retreat of ice in the Laptev Sea. You can see this is a 22nd of June image. You can see a significant amount of open water here on the right. And then this is on the left is the time series. And generally, you don't start seeing significant ice loss in the Laptev historically in terms of the 1981 to 2010 average until July. But we were seeing a pretty substantial drop even in late May. And we had record low levels during the end of May and through most of June. And then it slowed down some and was still much below normal, but not the lowest that we had seen in record until, again, in August, we saw slightly low, record low levels there. And largely because of that, but also low ice in other areas, we were heading towards a potentially a record low or on a record low pace by early into mid-July for a few days. And so it was looking like it was going to be a pretty extreme low, maybe not a record low. I think at that point it was too soon to really say that, but it was looking quite extreme. But things changed pretty dramatically in July and into August. We went from being at the lowest at that point of the year in early July. By middle of August, we were only 11th lowest because it was a very slow retreat. In kind of the end of the first week of August, we even saw basically no ice loss for about 4 or 5 days. If you can see my arrow here, where it was basically flat. And the reason for that, or at least one of the reasons, was a change in pressure patterns. We saw quite a bit of low pressure, which I'll get to in a minute. But particularly, like, this is the August 6th, 12th, where we were basically flat as far as ice loss. We weren't losing any ice. You see this kind of dipole type of pressure pattern that led to an outward flux of ice, kind of pushing the ice edge outward in the Beaufort and Chukchi Sea region, and little retreat elsewhere. So, and that was kind of a pattern that we started to see overall in July and August. This was a particularly extreme area, but in the overall, again, we had kind of low pressure and I think fairly weak pressure gradients. So this is on the left, June, July, and August of 2021, and quite strikingly different than what we had seen in other recent years. This is 2020, just as one example. And the low pressure brought kind of cooler temperatures, cloudier conditions, so really kind of dampened the ice loss. A couple other interesting things I think worth mentioning, maybe worth discussion more later. But one of the areas that was particularly low was the East Greenland Sea. We've seen this before where the East Greenland Sea kind of clears out of ice, but this year was particularly extreme. This is July, mid-July. There was still a little bit of ice there, but through most of the summer after that period, very little ice, and it's only now slowly kind of regrown. And I think that's an interesting feature. And then despite the low conditions in the Kara or in the Laptev Sea and in the East Siberian Sea, the Kara Sea kind of kept this one area of ice kind of persistently along the Severnaya Zemlya Islands, I think that's right, where it kind of was almost blocking the Northeast Passage, or at least largely blocking the Northeast Passage. And that persisted pretty much almost through the end of the melt season. And another area that I mentioned, the Beaufort and Chukchi Sea, oops, let me go back here. You can see here, it was pretty much near normal as far as the location of the ice edge, well into August and almost through the end of the melt season. So that was that multi-year ice there. Let's see, so we ended up with a pretty modest September, 4.92 million square kilometers, with only the 12th lowest in the record and the highest we've seen since 2014. So compared to the most recent years, it was quite modest. However, it still was far below what we had seen before 2007. It still keeps, the last 15 years have had the 15 lowest extent in the 43-year record. And the trends are still quite steeply downward, and not much change in recent years. And I think one of the things that happened was that the thicker multi-year ice in the Beaufort and Chukchi kind of saved the ice. It was really starting to melt out in earnest towards the end. This is from the University of Bremen, the ASI algorithm, which provides a little more detail. And you can see openings in the ice cover north of Alaska, some scattered ice north of Wrangel Island, and quite a lot of more concentration ice there that was, a little bit more time, another couple of weeks, that probably would have melted out. But it hung on because the ice was just thick enough and the conditions were cool enough and not as conducive to ice loss that ice hung on. So it was an interesting scenario, a little bit different than what we've seen in recent years, I think. We didn't we didn't have it's quite an extreme year, but that multi-year ice that infected into the Beaufort and Chukchi, like I said, a lot of it did melt out late, some hung on, but overall, what we see is the multi-year ice now going at the end of the melt season, going into the refreeze period, was the second lowest in our record, just barely above 2012. I would consider it within the margin of error of 2012. And so, we've seen kind of an interesting pattern now the last few years where it goes up for a couple of years and then goes down. And we've now been in a down cycle. But the oldest ice, the ice that's over 4 years old, has been pretty persistently near zero since about 2012. Little bit of ups and downs, but less than 500,000 square kilometers consistently since then. So the ice, we get some multi-year ice, we get an infusion of multi-year ice. It might stay around a couple, 3 years, but it's not staying around like it used to longer than 4 years. So that's a big change that we've noted before in earlier years, but it continues, this loss of the older ice. Finishing up, and this will lead into Ed's presentation and further discussion. This was just the summary of the outlooks. This is the August outlooks. And you can see, by and large, we were quite a bit lower than what things ended up as in terms of the observations, which is a solid gray line here. And this is the median, the dashed line. So everything was quite low comparatively. If we look at breaking it out by the predictions for all the 4 months, and this is the first year we've done September. So this is, going from left to right is June, July, August, and September for the 4 months. And one of the things that to note here is that people that submitted in June could carry over, or July could carry over their outlooks into the following and subsequent months. So they don't necessarily adapt. And this is what happened here with the heuristic. They're all the same. They were all submitted in June, and nothing was updated. So that's not necessarily indicative of skill as we get closer to the minimum. But the statistical, there were some updates, and there was a movement towards the observed extent. Also in the machine learning, somewhat in the modeling, although the median dropped quite a bit in September, and again that may be related to the lack of update in terms of the models for the September runs, and Ed will get into that more, and I think that's worth some discussion. But overall, things were quite low, although some of the range, the 95% range, did encompass the observed, at least in August and September. So there's this was a year that I think had somewhat lesser skill, partly because of the kind of quite large change in conditions, where we were heading towards a record quite low in early in mid-July, and then things slowed down a lot in July and August. And so it's quite possible that the change in conditions were not able to be captured by the prediction methods. So I will stop there, and we can open up for discussions or questions.
Thanks, Walt. I think we'll leave your slides open so people can refer back to other slides. That was a great presentation. Thank you very much. As a reminder, if you're joining by Zoom, you can either type your questions into the chat window and I will read them aloud, or you can raise your hand to indicate that you want to speak. And if you're joining by phone, you'll raise your hand by pressing *9. I don't see any questions right now. I'm hoping that maybe Doug can lead us off again with a question. This is meant to be a very informal conversation, so if people have questions that they want to ask.
Thank you, Betsy, for putting me on the spot. But
Yeah.
I do have a question. Gosh, I don't know how many slides back it was, but the persistence of old ice 4 years and older. It's a, as I recall, that's normally along the northern coast of Greenland and up in Ellesmere. Is there any indication that you're saying that the edges of that are breaking up, that there's a distance between the shorelines and the old ice, or is it just simply a decrease in place?
So that's a good question. So there's been, I think, several things going on. In the 90s, you can see this kind of downward trend in the 90s or late 80s into the 90s.
Right.
That seemed to be a lot of advection out of the Arctic through Fram Strait, where there was an increase, the circulation pattern, the positive AO. But then since about 2005 or so, where we've seen that, that's kind of second step down, that's been a lot of, there's certainly still been advection, and it's just not replenishing. There's not as much ice growth, and the ice is moving faster. That's another thing we've seen, sitting out of the Arctic faster. But we've also seen quite a bit of the older ice melting out within the within the basin, particularly like the Beaufort and Changtse Sea. I mentioned that this year, where we had quite a bit of ice there, that definitely slowed the loss of extent, the loss of the ice there. But eventually there was enough energy that it started to melt out. A lot of it, or at least some of it, hung on compared to recent years, but it's still melting out. There's also been quite a bit of, and I didn't mention this, but this year again, the Wandel Sea on the northeast corner of Greenland, which has been an area of the thick multi-year ice, that did open up some this year. We've seen that a couple times in recent years where the ice is pulling away, which also probably helps it melt out some or advect quicker through Fram Strait. So we're seeing, I think, kind of the multi-areas kind of getting attacked, so to speak, on all sides. I think most recently, the biggest thing has been the loss of ice within the Arctic, that we hadn't really seen before. That was, only small amounts would melt out, and now we're seeing larger amounts melt out, particularly in the Beaufort and Chukchi Sea.
Thanks, Walt. We have 2 more questions or 3 in the chat, and then a couple of people have raised their hands, so I'll read the chat. 2 questions from the chat first. The first is from Harry, and he asks, in the maps of the sea ice extent, the median ice edge for 1981 to 2010 is given. When will NSIDC switch to the 1991 to 2020 median?
Well, that's a good question. We've had several people ask this. We're at the moment, although we certainly would take input from the community, but at the moment we've decided to stay with 1981 to 2010 to provide a more consistent and continuous measure. I know the National Weather Service does their climate normals and updating theirs. I think the purpose is a little bit different. The National Weather Service is focused on weather and kind of expected, quote unquote, normal conditions. And those are going to be like what you've experienced over the last 3 decades. And so I think it makes sense to change those. But I think our purpose, as we've looked at it, is as a climate in assessing climate change over the long term. And so I think keeping a standard 30 years constant, the 1981 to 2010 is in my view a better approach, although again, I'm certainly willing to listen to other rationales. The other thing is, a climate normal is meant to be, or at least I think it should be something that's relatively stable to compare to. And certainly 1981 to 2010 is hardly stable in terms of Arctic sea ice, but it's more stable than 91 to 2020. Where you really have, you'd be averaging in all 15 of those lowest years or 14 of the lowest years in the record, which is going to really, in my view, skew kind of your comparisons. Ultimately, it's just a baseline in my view to measure against. It doesn't change the raw numbers. It doesn't really change your conclusions. It would make the earlier years more anomalously high and the later years less anomalously low. Your percent per decade trend would increase in magnitude because you'd have a lower baseline. But again, I can see the desire to kind of update, but right now we're kind of thinking to keep it the same. So,
thanks. And then the next question that was in line was from Christian Dumard. He said, "Do you consider that the Northwest Passage opened in 2021?"
I would say, well, one of the things for these passages, we are pretty careful about this because the satellite, our passive microwave satellite data is pretty limited in terms of the resolution, in terms of really assessing conditions. And there are some interesting differences even within the Arctic basin compared to what we see in the passive microwaves versus what operational ice centers see. But basically, from what I've seen, even in the passive microwave, if you kind of look at the, let's see if I can bring this up, even like the Bremen, which is higher resolution, gives us pretty good detail, better than what we have. There's still quite a bit of ice in the Northwest Passage. And so I don't know of any specific shipping that went through there. Certainly, I think it would have been probably possible with icebreaker capabilities. I guess I think the Healy went through actually. I probably should know that, but generally speaking, in terms of like shipping container ships or something like that, it was a relatively heavier ice year than what we've seen in recent years. I know the Northeast Passage, I know there were ships that went through there, even with this ice in the Kara Sea region there that kind of piled up and kept ice there. There was still, I think, ability to sail through there. So I would defer to the specific, operationalized centers on whether something's technically open or not. But my thing is it's probably not for the Northwest Passage.
Thanks. And we'll go to a couple folks that have their hands up first, Ed, and then James. Ed, can you go ahead and unmute and ask your question? Thanks.
Hi, Walt. I was really curious by the map you showed of melt onset anomalies, and I know you mentioned how early the anomalies were in the lap turf, but if I remember correctly, they were quite low or quite late in the Beaufort-Chukchi, right? And we know that there's quite a few papers that show a correspondence between melt date anomalies and September sea ice conditions, and I was wondering if part of the story in the Beaufort and Chukchi with the relatively more sea ice there than in recent years is not just the multi-year ice, but that you had a slightly colder late spring, early summer, and a later melt onset.
Yeah, that's a good point, and I didn't really mention that, but as you can see here, yeah, there's the blue here are a couple weeks late, maybe even a little later. And yeah, I'm sure that played a role as well. That's an important thing to add. I appreciate you mentioning that. I mean, it's interesting. There was early melt right along the coastline, which is where the thick ice had built up, probably mostly. So the thick ice there probably, even though it was early right along the coastline, delayed things. But farther out, where normally the ice had been retreating, there was definitely later onset, and that implies cooler, cloudier probably conditions there that did delay the melt onset and delay probably the loss of ice there. So that's a really good point. Thanks for mentioning that.
Thanks, Ed. And then Jim Overland has his hand up. Jim, could you unmute yourself and ask your question?
Yeah, I wonder if Walter, Mark Therese, or Thomas Ballinger want to say, is there anything consistent about the summer highs and lows in the Arctic, or is it all random?
Well, Jim, you'd probably be good to answer that too. To me, especially this year, it seemed like there was a fair amount of randomness to it. The conditions kind of went from one high in the winter and early spring to low over much of the summer, which again was quite a bit different than what we've seen in recent years. I don't think there's anything that stuck out as being unprecedented this year in terms of the atmospheric circulation or pressure. It was different than kind of a lot of things that we've seen in recent summers that I think made it a little bit of an odd summer and probably made it somewhat difficult to predict. At least that would be my guess.
If I can chip in, and I'm also referring to Mark Therese's question in the chat. I personally, I haven't seen much evidence or any evidence of operational skill in forecasting like seasonal summer circulation in the Arctic. But there is, I think any hope might come from teleconnections from the Pacific. And I know Qinghua Ding and his students have done quite a bit of work on this teleconnection between JJA, circulation over the Arctic, and teleconnections to Pacific SSTs. But it seems relatively weak. And actually models, a lot of models don't show that teleconnection. So it could be a model bias, but my own take is that there isn't a huge hope for forecasting summer, like at long lead times, summer circulation, but that might be a small hope to cling on to.
Yeah, thanks, Ed. Yeah. Thanks for answering that. Yeah.
And just so I'll get to Nick's Sun questions in a second, but Mark Therese's question that Ed was referring to was, do we have any hope of predicting with any skill whether a summer will have basic cyclonic or anticyclonic type of atmospheric circulation? Mark, did you want to follow up on that?
Yeah. I just wanted to say, when we get at this issue that we we seem to do well when we're near the trend line, but not so poorly when we're off the trend line significantly. And it really seems to be this cyclonic versus anti-cyclonic summer that determines whether we're on the trend line or not, you know? And so it seems like a very high priority thing to do to see if we can get any predictability there. But as Ed's saying, boy, we haven't made much progress.
Thank you. Nico's son made a comment, and that is, he said that for my forecast, I did a correlation analysis for sea ice concentration and sea ice extent. 2021 correlated very well with 2014 and 2020. Extent and concentration was mostly a mixture of these 2 years. Nico, did you want to follow up with that? You could unmute yourself. Okay. And then I see that Edward, your hand is still up. Did you want to have something else? Did you have something else you wanted to say?
No, I'm just slow.
Okay.
So let me lower my hand.
Okay. And Mark, did you have something else? Did you have another point to make? More discussion?
No, sorry, I forgot to.
Okay, I'm just checking. No problem. Well, I want to, and Nico's son says that was just for my forecast method 2021, wasn't unusual or exceptional, was what his followed up with in this chat.
Yeah, I think that's interesting, you know, that he said this is the highest since 2014, so that there was good correlation between 2014 and this year makes some sense. And it's kind of, yeah, I think it's interesting. So yeah.
Well, we have a few minutes remaining, but I think that it feels to me like the discussion for this section has concluded. Does anybody else have anything they want to add to this one before we go on to the next presentation?
The only thing, Betsy, I'll add, there wasn't any question on it, and I didn't put anything in here because I didn't want to take too much time, but you know, sea surface temperatures are another potential influence, and the temperatures were somewhat cooler and not as widespread warming, which is indicative of cloudier conditions and cooler conditions. But that also may have played a role. So maybe that's something that can, just throwing that out there for further discussions, maybe after Ed's presentation, when we start talking more about, you know, the predictions and the skill, and particularly regionally. So.
Okay, well, thank you very much. I think then we'll go on to the next speaker. Our second speaker is Edward Blanchard-Wrigglesworth, and he'll provide a summary of the skill of the 2021 SIO sea ice probability and extent forecasts across models. Edward Blanchard-Wrigglesworth is a research professor in the University of Washington's Department of Atmospheric Sciences. His research interests include atmosphere, sea, and ice, ocean, atmosphere, sea ice, ocean interactions, and Arctic sea ice probability. Ed, will you take over the program now?
Hi, Betsy, thanks. This will stop. Yeah, okay. Okay, so I hope you can see this.
Yep, we can. Thank you.
So I wanted to, I know Walt showed that figure, the sort of chart figure or bar figure of the different forecast methods for the 4 different months. And he did mention that those are kind of taken from each month's outlook, and that they include forecasts that have been repeated, because we do give the option to contributors to, you know, they submitted a forecast in June, that they can use the same one in July or, you know, in later months. And, you know, that makes comparison a little bit difficult sometimes, because when we, you know, when you see the forecast evolve from one month to the next, well, we know that we're repeating some forecasts. So I wanted to basically make the same kind of figure. It's not quite so pretty, but I've just gone into the database and I've just selected the unique forecast for each month. So all the values that you see in this figure they are the sort of specific forecast for that month. So one would hope that they have similar lead times to out to September. And actually, the storyline is similar to the figure that Walt showed, is that there is a slight improvement in the forecast as you get close to September. And I've color-coded it by methodology. So you have the dynamical models in black, machine learning in red, and statistical in blue. And if you take the means, of all these forecast methods, as you're probably eyeballing it, they do get slightly better. So the means, they start around 4.3 or 4.2, 4.4, and by the September forecast, they're doing quite a bit better. And it's interesting that the methodologies that seem to update the most from August to September is the machine learning. But even what I think is really interesting is that even in September, and again, these are forecasts that have not been repeated, right? So these September forecasts were made in the first week of September or maybe late August, and you can see that there's still many forecasts that were predicting much lower sea ice conditions than what we observed. The horizontal gray line is the observed September extent, 4.92. So you can see that on the whole, we're forecasting too low of sea ice conditions, but the forecast did improve as we got to September, but did they even improve enough or as much as one might expect? And I know hopefully you remember from Walt's presentation that the rate of sea ice melt really slowed down in July and early August. So maybe the June and July forecast can have a bit of an excuse, but by August and September, I think we were seeing evidence that it was going to be a relatively high value, or at least not as low value as the last few years, or some of the low years we've seen. So I wanted to focus. The other thing that I really want to thank everyone, the contributors, for submitting that September forecast, which was additional this year. And I think it's really useful to learn about the skill in these models and the spread across them. So I want to focus a little bit on this last September forecast. And this is just a time series of daily sea ice extent. I'm sure a lot of you will be familiar with this kind of figure. It's from the NSIDC Sea Ice News portal. And I've just plotted the daily extent here from a number of years. And you have the sort of the kind of climatologies and quartile ranges in grays, in the gray shading, and then individual recent years in the colors. And something we know is that kind of by the end of August, like September, sort of a lot of the kind of answers baked in, right? And we know that the correlation from August anomalies to September anomalies is the highest 1 month lag correlation of the whole year. So you can see that if you know where you are on September 1st, you have a pretty good idea of what your September monthly sea ice extent is going to be. So I was thinking about this as I was looking at those September forecasts, and I thought, well, can we maybe quantify a little bit more? If I know where I am on September 1st, what is my expected range for the whole month? So I did what I'm calling the Walt Meier model, because I showed him this a few days ago, and he's like, yeah, that's how I make my model. So what I show here is it's basically a forecast of September daily sea ice extent, starting on August 31st with the observed 2021 value in August 31st, which was about 5.2 million square kilometers. And it's very simple. What you just do is you add to that value the tendencies of each single year in the past 30 years, right? So there's a 34 time series, and I'm just going back to 87 because that's when the daily data started. And you do that, and then you just make a monthly September sea ice extent for each of those trajectories. And what I plot on black is the actual observed September 2021 trajectory. So you can see that basically using historical rates of sea ice tendency or sea ice evolution from August 31st onwards, all values are between about 4.9 and 5.4. And the sort of interquartile range is between 5 and 5.2. So this is, if we could go back in time to September 1st or August 31st, this is sort of what, we would expect. Basically anything beyond this boundary would require unprecedented rates of sea ice change within September. And these colored values are the same from the previous figure, but these are our September sea ice outlook forecasts. And I do know that we requested these on the 10th of September. So you could actually constrain this, this sort of answer using historical rates even more if you did the same exercise, but instead of starting on August 31st, you start on September 10th, your range will be even tighter, right? So, a lot of, even though, as I showed in the previous figure, that there had been this improvement from June, July, August, September, as forecast we're forecasting slightly higher sea ice extent values. Even at this very short lead time, there's, there are sources of errors in models that that you cannot really account for with like physical processes, right? So I think that there'll be to know this, I think is valuable, and I think it'll be really interesting to dig more into, what's accounting for these really low September values when contributors are making these forecasts in early September. Okay, and something else I wanted to show, which was also new this year. So we have new September forecast, and the other factor that we, or the other new aspect that we invited was to for people to contribute anomaly extent forecasts. And you can read here, actually I copied and pasted this sentence from our, I think it's the first Sea Ice Outlook call that we had. And we've this is a topic we've been talking about for several years now, is that the range across all forecasts is really much bigger than one would expect. And so we've always wondered, well, is it because simply they have different climatologies, and what in a specific model 5 million square kilometers might be normal, but in another one that would be 4. So they're both forecast in normal conditions, but one is 4 and the other one is 5. And so if you just forecast the anomaly within the model world, would you get sort of a narrower range of forecasts? And this is something that's done for ENSO forecasts in GCMs, right? They forecast sea surface temperature anomalies in the Pacific, not absolute temperature ranges, because there's a big bias in the absolute temperature range, but they do much better in forecasting anomalies. So here I'm showing a similar figure to the one before, but I've just selected the models or the contributors that had both absolute extent forecasts and anomaly extent forecast. And I haven't color coded by methodology, so these are all 3 methods thrown into the same pot. And so I just show you here the absolute sea ice extent forecast, and in blue now are the anomaly sea ice extent forecast. And I've lined up the y-axis so that the observed value, which was 4.92, is the same as the observed anomaly, which is 0.7. And the observed anomaly is the distance between the value, 4.92, and where your linear trend from 79 to 2020 would take you to 2021, which would be 4.2 million square kilometers. So couple things. The scale of the anomaly forecast is no better than the absolute values. In fact, it's a little worse. That blue line is further away from the gray line. So in terms of anomaly forecast, the right forecast would have been 0.7. I don't think these differences though might be significant just because of the spread, but I haven't checked that. And then the other kind of take-home message is that the spread, the spread for each month across the anomaly forecast is no smaller than the spread for the absolute forecast, which is not what we expected or hoped. And I don't really understand it yet, but I think that's pretty interesting. So again, there are models that even in September, a few models are forecasting anomalies and negative anomalies, or even at neutral, and others are over 1 million square kilometers. So really big range here. So that's something I think hopefully maybe we can discuss or think about in the future. And then I do wanted to briefly show a little bit the sea ice probability forecast. Again, thanks to the contributors that add these to their forecast. Every year we have about 10 or a dozen. And you can kind of pick your favorite model or several of them and see how they did. The black contour I've added here was the observed sea ice extent edge in September. So kind of what the forecast is was aiming for. And I've also added on the right as a benchmark, if you just choose the last 14 years, kind of the new Arctic, so from 2007 onwards, and you use each September to make a climatological forecast, you would get that figure on the right. These are from June. And I guess also the other thing too is that what's interesting about looking at the climatological forecast on the right is that by looking at the difference between this year, the black contour, and what you would have forecasted simply using the last 14 years, you can see where maybe conditions were relatively normal this year compared to the last 14 years, and then or not normal, and you can see that in the last 14 years, you wouldn't, or using the last 14 years, you wouldn't have predicted this much sea ice in the Chukchi or the Northeast Passage. Was in other regions, it was more similar to what we've been seeing over the last decade and a half. So I'm gonna scroll through to August, and a lot of pretty much every panel is lined up with the same model, and you can see that there's not a huge amount of change, but again, you can pick your favorite model, and you see that there is a few models do have improvement, that they start getting a bit more sea ice in the Beaufort Chukchi, and maybe they line up with the East Siberian sea ice edge here. And to quantify that, you can calculate these are area weighted Breyer scores. So basically you just take the difference between the forecasted probability and the observed value, and you square it, and then you take an area weighted average. And we've had this in previous years' post-season reports. So a bit of a mixed bag. This can be a fairly punishing metric, but I will say that, like in other years, when you take the multi-model mean, which is this panel here, it's actually the most skillful model that we have, and we do see improvement from June to August. And then something that's maybe slightly less positive news is that by using the climatology forecast, these are the values, and it's pretty hard to beat climatology, especially in June, although by August maybe half the models do, but not by very much. So that is, I don't know how I'm doing for time, Betsy. But that's
you go ahead and finish up. We've got we have buffer time, so
well, that was kind of the main bit of my presentation, but I did do one final figure. I literally saved this right before the I saved this right before the presentation, and going back to those forecasts of the absolute sea ice extent and then the anomaly forecast, I was curious to see how they related. So does a model, so if you had a kind of perfectly calibrated models and every model had the same climatology, then these two variables would be sort of, correlated perfectly, like one to one, right? And you can see here that there's actually quite a bit of spread and scatter for each month, right? So each value is a single model, and you can read the x-axis is the forecast they gave us for the sea ice outlook in millions of square kilometers, and then the y-axis is the anomaly. So you can pick pairs of points. For example, these two extremes, they have a very different sea ice outlook forecast. One's 4.7, that one's 3.9, but they almost forecast in the same anomaly. And in that case, that's what we were hoping, that the range of anomaly forecast would narrow, or compared to the absolute. But you can see the opposite case, right? That there's models that forecast similar CI's values, like around 4.3, 4.4, but to a model that's a negative anomaly into another model that's a much stronger positive anomaly. I thought this was interesting, but I know I've shown quite a bit, and there's hopefully some issues to talk about, so I'll stop there.
Thank you, Ed. That was
Okay,
really
I'll
interesting.
keep it up.
What?
I'll keep the presentation up.
Yeah, to keep the presentation up so people can ask questions. Thanks. And just as a reminder, if you're joining by Zoom, please type your questions in the chat window or raise your hand and call on you just like we did the last time. And if you're joining by phone, raise your hand by pressing *9 and unmute yourself by pressing *6. I don't see any questions or hands raised at this point. So is there someone that would like to lead off with a question? This is meant to be a good, just kind of informal conversation back and forth between participants and the presenters, or even between participants. So please don't be afraid to speak up. Harry asks, isn't machine learning just a form of statistical forecasts?
Yes. We want to, I think, I can't remember how we had the original discussion of having them split separately, but I think maybe it was to highlight machine learning as a new subtype of statistical model, since there's quite a bit of hype about them.
And Uma asks, Ed, do you have any thoughts on the next step for anomalies?
No. I'm just baffled a little bit at this figure, that the range is not shortened or become smaller, and the skill is no better. So I think a way that we can learn is that since these issues last till September, and a lot of these September forecasts just something's up with the skill of these forecasts, right? You're just forecasting values that are unrealistic, at least from knowing where the real world was in early September or even late August. So there's other sources of error, and I think one way, and I was thinking about, I don't know if Mitch is on the call, and he might want to comment, is that, we've been talking about this into comparison, using different, all the contributors and sort of looking at the hindcasts. And I think that would be key to understand this, because, yeah, I'm glad we did this, but it's not the result I certainly expected.
Jim Overland has a question. Jim, do you want to ask your question?
Yeah, okay. Can you
Yep, we can hear you.
see any reason at all for a bunch of the models hang out around 4 or below?
Well, I would have, before making this kind of figure, I would have said, well, that's maybe because the climatology is too low, and by looking at the anomaly, they'll do better. But no, I don't. I mean, if you just look at the absolute value in dynamical models, yeah, it's easy for a dynamical model to have 4 million square kilometers just because that's its climatology. But when you bias correct, that, if you have skill, you should be around 4.9 or an anomaly of 0.7. Now, the expected linear trend for observations is in the low 4s, 4.2. So if you'd made a climatological forecast for this year, you would be a 4.2. So if you don't have much skill, then you're going to be probably in the low 4s around that climatological forecast.
Thanks. And then Mike Steele has his hands up, and then we'll get to Mitch Bushek's question. Mike, do you want to ask your question?
Yeah, sure. I mean, I'm trying not to be depressed, Ed. I can see you are.
I'm
So
not depressed. I'm just fascinated.
fascinated. Okay, that's a better way of viewing it. So your results make me want to do some kind of model intercomparison project. You know, I mean, make me want to do something where we constrain the models in some way. Give them, I don't know.
Well, we did that in the past, and we showed how important it is to bias correct, right? So 4 years ago, several people on this call, with several people on this call, we organized an intercomparison forecast where we all use the same, all the models use the same thickness in the central Arctic on May 1st. So as they started the June forecasts. And by September, they all had different sea ice thickness and sea ice volume, very different, even though they had all the same initial conditions. But so they were, and they all made very different forecasts of September sea ice extent, all using the same sea ice thickness. But when you bias corrected, so we run a second set of runs where they use the climatological sea ice thickness, and we bias corrected by simply taking the difference between the two exercises, the two sets of runs. All the models agreed with each other and actually made a decent forecast. So we know, I think that's still something we don't really understand very well. We know that different groups do bias correcting differently. They have, the hindcasts have different lengths going into the past, but I do hope that with the work that Mitch is leading, that we'll learn more about this. But I mean, I hope this will be motivation for individual contributors, especially maybe those that submitted in September, to understand better, why sort of just a few weeks out. I mean, just as we start in September, the climatology and even the statistical models, right? Because some of these September forecasts are from that are really low, remember that the red and the blue are the statistical and machine learning. Even some of these models are way outside what would be an expected September forecast. And as I say, this is starting August 31st. So, I just hope this is sort of kind of motivation, and maybe we'll, hopefully we'll understand these results better.
Thanks. I'm going to read a question from Mitch, and then John Walsh has a question to ask that I'll call on him. Mitch asks, did the groups that submitted anomaly forecast bias correct their SIO extent forecasts, or were the SIO extent forecasts raw?
That's a good question, but I think they submitted the sea ice outlook forecasts were the same as everyone else, that they, would do ask or invite, so when contributors invite or submit their sea ice outlook extent, that's kind of the very last step in their forecasting methodology. So any bias correction or they do is included. And I'm pretty sure we didn't ask, if you are submitting an anomaly forecast, go back to your absolute sea ice outlook forecast and give us the raw one. No, I think it was kind of the same category as for everyone.
Thanks.
Yeah, I guess just to follow up on that, Ed, I sort of assumed that if a group was capable of computing an anomaly, they would correspondingly bias correct their SIO forecast, which I think is what most groups are probably doing. But I was stunned by those scatter plots you showed. I would have thought those would all be on the one-to-one line on your extra slide. So the fact that there was so much spread indicates that something strange is going on there. And
right.
I found that very shocking.
I agree, and I don't understand it yet, but this is all very recent analysis. But I hope we'll use this as kind of as motivation going forward.
Yeah, great.
Can I ask a follow-up too? So you reminded us that there was some kind of a MIP where everybody started with the same thickness, and that didn't work. Could there be more MIPS where everybody starts with the same something else, or everybody has the same this or that? I mean, basically search parameter space or something that might work better.
Yeah, I mean, these experiments, they did take a lot of time and effort for everyone involved.
Yeah.
But I think it'd be up to the community to get together and decide that.
Yeah.
Yeah, I think John Walsh had a question. John, can you unmute yourself and ask the question?
Yeah, am I unmuted now?
Yes, thank you.
Okay, good. Yeah, my question's on that previous slide, the one with the evolution through September. I'm sort of amazed that most of the models on September 1st are predicting unprecedented evolutions through September.
Exactly.
Are any groups actually trying to do some post-processing or model output statistics type approaches, or even machine learning, so that models can learn to avoid that type of unrealistic forecast?
I mean, in theory, yeah. I mean, in theory, this is what groups are doing, right? That they are bias correcting and post-processing so that yeah, you don't end up with a forecast of 4 million square kilometers in September, starting in early September. This is when I invite, I hope as a messenger, I don't get shot too badly, but this is what I kind of want to throw a positive spin on this, to use this as motivation to dig into the forecast. And if you're one of the contributors and you're on the lower end, I certainly don't want to put names on these, but if you're on the lower end, to kind of go back into your methodology and try and understand, well, why are we forecasting these sort of unrealistic values?
Thanks.
Thanks. In the chat, Jim Overland writes, I recall for the IPCC models that were initialized the same, that they all went back quickly to their own climatology. Does anybody want to comment on that?
Well, I mean, that will happen over a range of many months or even a couple of years. I mean, for sea ice extent, a little faster than, say, sea ice volume or sea ice thickness. But when you're making, sub-seasonal forecasts, and that's where the bias correction comes in, right? Because, but this is an issue in many aspects of environmental predictability, right? It's not new to sea ice forecasting.
Thanks. And Jeff Curry has a comment, says, seems like the forecasts have a functional fixedness where they have predicted a trend for a period of time, which makes them reluctant to, quote, reset, end quote, based on recent observations.
Yeah, and I don't know if Francois is on the call, but he's been looking a little bit into this, that there is a year-to-year correlation in the forecast. So we saw this very clearly in 2012 and 2013. So 2012 was really low, and then in 2013, all the forecasts were really low, expecting another kind of a repeat of 2012, and 2013 in observations was much higher. And then the following year was then all the forecasts were pretty high for 2014, kind of thinking that, basically repeating the previous year's forecast. And there is a year-to-year autocorrelation in the forecasts that we don't see in observations, and we don't really understand why the models are doing that. And it's across both dynamical and statistical models, which is a bit strange.
Thanks. Mike Steele has his hand raised, but then so does Mike. Go ahead, and then we'll ask Richard Cullither after you talk.
No, I just lowered my hand, sorry.
Okay, thanks. Richard Cullither, can you unmute yourself and ask a question?
Hello. So our group did not submit a September forecast, but one of the things that we've been looking at closely with our model has been the initial shock from the initial conditions. And so it's kind of occurred to me that as you get closer to the September time period, you've shortened your lead time and you're more susceptible to the shock in the dynamical models. And so perhaps that there might be a clue with these unusual September forecasts with that. And the other thing I wanted to say was that Renew Joseph has been interested in coordinating a model intercomparison project through IARPIC. And so if there is community interest in doing a MIP, perhaps IARPIC could help out on that.
So, Richard, thanks for that. That's yeah, that's very interesting, and to have that perspective from from the contributions. But so one of the things I was curious about in terms of the shock is that I can understand from a physical perspective how that might happen during your melt season, but by early September, whether your model has a low or high climatology, you're kind of at the end of the melt period. So I might have expected that shock to be reduced because otherwise, basically the implication of the September forecast is that you're losing over 1 million square kilometers in early September right away after the forecast period. But as I say, it's not just the dynamical models, right? There's statistical and machine learning forecasts of September that are really low, and sort of unrealistically low.
Yeah, I guess I would just add that when we've been looking at our models, some of these shocks that we see within a few days of the initialization can be, not associated with physical processes, but like, for example, the numerics, like we see a contraction of our sea ice by 1 grid box within a few days of the initialization, and we've kind of tried to trace that down. And so there can be other things associated with the dynamical models, but I take your point that this is showing up in the statistical and machine learning models as well.
Well, thanks, everyone. I think that it's time to move on to our third speaker. That was really great discussion and exactly what we were hoping could happen today in today's webinar. Really appreciate everybody's discussion. That was great. Our final speaker is Uma Bhatt, and she will provide an overview of lessons learned from the 2021 Sea Ice Outlook and the SIPN2 project. Uma Bhatt is the lead principal investigator for the SIPN2 project. She is a professor of atmospheric sciences at the University of Alaska Fairbanks. Her research specialty, climate variability, aims to understand how one component of the climate system impacts another. Uma, will you take over the screen and the presentation?
Yes. Hopefully you can see my screen.
Yep, we can see your screen.
All right, now, this last part is really reflecting on what we've learned over the last 4 years. And it's, in a sense, it's just a start of what we've learned. And so this is a plot of sea ice and its Arctic sea ice and its trend and where our sea ice SIO medians sat. And I think in all of this, one has to stay optimistic, because otherwise you just give up and you throw your hands up in the air, even though, we're faced with a bunch of challenges, and how are we going to go forward? First of all, I'd like to acknowledge all the personnel, and I like making word clouds because sometimes art can help you think creatively. So this, the brain here shows all of our contributors over the last 4 years, from 2018 to 2021, of the SIO for SIPN2, and at the bottom are the team who related to the SIPN2 team that helped put together or synthesize all of the inputs. So again, it takes a lot of brains in order to get this work done. So if I look back at what our goals were for SIPN2, and there were 5 goals, and I'm going to really focus on the goals of those goals that were related to the sea ice outlook. So one was evaluate forecast method, and the second goal was to evolve the network and further develop network activities. And the third goal I'm going to talk about is evaluate the socioeconomic value of sea ice predictions. And it's kind of a grand statement, and it's been probably one of the most challenging. Lots of challenges here. So first, some of this is going to be repeated from things that have been said thus far. This shows the anomalies, the observed September anomalies over from 2008 onwards during the SIO, and the SIO July median scores. So you can see that based on a paper that was written by Larry Hamilton and Julian Strova, we're good at getting the trend, but we're not as good at getting the anomaly. And as Ed just mentioned earlier, if we look at the correlation, we're actually better at getting the anomaly from last year. So there's a persistence in the forecasts, and the correlation is actually quite high. And again, Francois wrote about this in the June 2021 SIO. And again, it doesn't, as Ed said, it doesn't matter which method. It's statistical as well as dynamical. And I think one of the things Francois put out there is it some human tendency that's changing methodology in order to persist from one year to the next. So again, this is another challenge or mystery that has come up that is pretty perplexing. So again, we want to understand what's going on here. I think one of the other points, and Ed also summarized this nicely, was the anomaly forecasts show more variability than we expected. And one thing that I found interesting when I looked at Ed's slides this morning is he and I calculated the anomaly differently. I only used data from 2005 to 2020 to calculate the trend, the linear trend. Ed used the whole period. So again, you know, one thing that has occurred to me is we kept this definition very flexible to encourage lots of people to contribute. And I think we want to tighten up our definition and going forward. One thing that is positive here is that the anomaly forecast root mean square error did get better between June and September. And a few of the models that did particularly well use statistical or machine learning here. And I think as we're going forward, I think we're kind of at a stage where we can start thinking about maybe being a bit more comparative about the models, and I'll get to that in a second. One of the other new things that we did this in this SIO was evaluate sea ice forecasts regionally. And I think this was, again, very interesting to focus on Alaska and see how we did. Here's a bar chart for 2020, comparing statistical and dynamical models. One of the key messages for both of these years is the statistical tended to do better than the dynamical. In 2020, the models were generally too high. In 2021, the models were generally lower than what verified. Again, this potential correlation from one year to the next might have a regional signal, so we want to look at that further or think about it. I think as we were at our last SIPN leadership meeting, we were talking about, we were expressing our concern that sea ice forecasting hasn't improved that much. And Francois Massonnet, you know, put a very, kind of brought us to, it made us think about, well, you know, Arctic sea ice forecasting is much more advanced than what we have for the Antarctic. The Antarctic is much younger. So I think we, you know, even with a lot of topics such as racism, we feel like we're not there yet, but I think we have to focus on the progress that we've made in order to keep going. And I think the spread and the skill in the Antarctic forecast shows us we have advanced in the Arctic over the last 30 years. So as one of the other topics that we focused on was the socioeconomic value of sea ice prediction. And, you know, I think one of the things that was very, very clear is there was a real interest and need for information, but there's still a gap between what we produce, how we communicate it, and what people want. And the closest, the community that we worked with in this project were the Bering Sea crabbers. And since we do S2S forecasts, seasonal, subseasonal to seasonal, the crabbers don't really look at those forecasts, and they haven't really even thought about how those forecasts might help them. They're looking at a much shorter timescale. However, the federal regulators that regulate the crabbing industry, they very much would like skillful forecasts of sea ice in the Bering Sea. Other industries that we talked to at a meeting that we attended in Tromsø was the tourism industry. You know, there's interest in open water for sea ice, open water season, or sea ice roads for particularly the extraction industry. There's interest in environmental safety as well as human safety. And though a lot of the human safety is very much concentrated on the landfast ice, which we don't predict operationally. And so I think some of the stakeholders that are probably closer to what we're doing and focusing on are scientists such as the Mosaic expedition, which we produced Fram Strait forecasts for them, and the SIDFEX experiment. So I think we, as we go forward, we want to really think about what stakeholders we want to focus on and how we want to reduce that gap. And I think we need to continue the conversations with stakeholders so that they know what we can deliver and we know what they need. And I think one of the final things I want to focus on is how the sea ice network has evolved and how we might want to further develop it going forward. And I think the forum in January was really eye-opening, and it was really stimulating, and it really made me realize how important this activity is as a community. And we had a public report that Mike Steele led that came out in BAMS. And there's a team peer-reviewed article that's in progress that Mitch Bushak is leading that came out of the forum. And I think, you know, one of the two most exciting things that came out of the forum were requests from the community to include September Sea Ice Outlook and the anomaly forecasts. And so I you know, kind of the community thinking is really what it's gonna take to forward, you know, advanced sea ice forecasting. And again, strengthening the community and the way that the community can interact is kind of an important part of the next step. And so as we're going forward, I think, you know, I think everybody agrees we need to improve sea ice forecasting skill. And one of the tools that we think will really help is a portal that we can use as a sandbox. Can we make the portal's been great? Can we update it so it's more interactive and easier to use? Additional regional forecast focus. We did Alaska this time. We've ventured a little bit into Hudson Bay, but you know, additional regional forecasting will likely help us link to stakeholders better. We've also talked about doing additional seasons besides September. Again, that's a burden on the contributors, so we want to make sure that that's something people are interested in and can move forward. And I think with the aid of the portal, we can really spend more time on answering why. I think we've identified all these really interesting facets of sea ice forecasting. And if we have some tools in hand, we can really focus on understanding why, which will help us improve our forecasts. And some of the ideas that we've thrown around is, can we produce a SIO multi-model forecast and a weighted forecast which evaluates weights based on how well forecasts are doing and really strengthen those collaborative activities. I think we would still continue the SIO report for September because that's a signature product and we want some consistency and we want to show improvement in skill, but we would potentially have brief reports. And as we go forward, we're trying to figure out how to manage the 2022 SIO season, since we're working on the next proposal right now, and it's not likely to be, you know, funded or ready before the 2022 season. So we're working on kind of these next steps. And I think the question I have for the community is, do people feel ready to do a more beauty contest type SIO? And in order to figure out how to improve our skill. And that is kind of where I'm going to end, and hope to get some questions on or comments on this. Thank you.
Thank you, Uma. Again, people can ask their questions in chat or raise their hand. And if you're joining by phone, you'll need to hit *9 to unmute yourself. The first question is from Harry, and he asks, seems like forecasts of the Northeast Passage opening and Northwest Pass opening would be of great interest to many stakeholders. Thank you, Harry. You want to respond?
Thank you. Are our models there yet? I'm kind of looking at the modelers in the group. Are we there yet in order to create those products? I guess you have to start somewhere, but
it seems to me that, well, others can comment on the models, but like the Northeast Passage might be a lot easier than the Northwest, because you could look at ice thickness and then potentially circulation patterns that, you know, like the Laptev opening up early with some indication, although even this year the Kara Sea ice blocking it. The Northwest is, I think, difficult because there's a lot of multi-year ice. There's advection in from the north. Exactly where the passages open up and how seems to me would be challenged. But I think it's a good point. I mean, those are two areas that are definitely of interest and would definitely have strong stakeholder interest.
Thanks, Walt. Mike Steele has his hand up. Mike?
Uma, I just wanted to ask a follow-up question. One of your last comments was, are SIPN contributors ready for more of a beauty contest? I just wanted to ask you what you meant.
I think what I was, by weighted SIO multi-model forecast, you have to evaluate how well forecasts have done, right? So up to now, we've been very neutral, partially because we didn't want it to be a beauty contest. We wanted everybody to be included. But I feel like the network has evolved. We're kind of at a stage where we might be ready for more comparative evaluations. And I know individually conversations I've had with people have gone down that path, but are we ready as a community to do that?
Thanks, Jim Overland. I saw that your hand went up and then went down. Did you want to say something?
I was just backing up Walt Meier's comment about the Northwest Passage, that there's a lot of eviction of ice out into the main channel, so it's more of a short-term meteorology problem.
Thank you.
Maybe people need more time to think about this. Please, contact me individually with your thoughts on this, because I really would like some thoughts beyond just the SIPN team.
Nico Sun writes, I think to be useful outside a modeling exercise, we need to provide daily values. Sea ice changes significantly over 1 month. A monthly average is too imprecise. Thank you, Nico.
Thanks. I think the other kind of new change that we've talked about is having more sandbox activity in the portal. And I know right now about 10 people submit to the portal, that we'd still have the opportunity to submit, single values, because not everybody has the spatial part of their forecast. But, submitting instead of once, for a September forecast, submitting for several other months, is that something that people are, doing anyway with their models, or would that be, how do people feel about that?
Uma, can I jump in, Betsy?
You bet, Mike.
Okay, Uma, I think that the whole idea of the sandbox is a good one. I would hope that if there's a next phase for SIPN, that there's a lot more community involvement, that it's not just, the executive team doing everything. And, we had our January meeting, and, your sandbox point. It's more of a wiki SIPN or something like that. I just want more community involvement. I think that's going to be great.
Yes, I totally agree with you, Mike. I think I feel like we're ready, and I feel like that's what it's gonna take to push sea ice forecasting forward.
We have a few more minutes, and I want to just let people think and talk. I don't want to close off the discussion too soon. Thomas Laverne writes, a question. I have not been involved too much before about the new September forecast showed by Ed. It'll be interesting for the contributors to look at what could have gone wrong, but fixing that will not necessarily improve their June or July forecast, seasonal versus midterm forecast. What is the focus of SIPN2? All ranges or seasonal? Good.
SIPN is focused on seasonal, from on the month, several month to 1 month time scale. And going forward, we're likely to focus on those same timescales, 1 month to several months.
What does subseasonal mean again? Like 2 weeks, right?
2 weeks, yeah.
Yeah, well, so September 1 was a 2-week forecast.
Yeah, we argued about that the other day. we're
And Mitch Bushik writes 0 to 8 weeks, I believe, in response to what is subseasonal. Is that?
Yeah, I think it's usually 0 to 8 weeks.
So I think we're at S2S.
Seasonal would be 1 month to 12 months, roughly.
Thanks, Mitch.
Thanks, Mitch.
Yeah, I can. That's a great comment by Thomas, and I agree that sort of understanding what's happening in those September forecasts may not necessarily improve June or July. It might, though, or at least reduce some of that model range. And I haven't done the exercise of going back in time. If I do the same for August 1st, like knowing where we were on August 1st or August 15th. Sort of constraining the kind of possible September values using that methodology. But I think it will help us understand too, because I've myself thought about, well, what should the focus in terms of lead time be for SIPN because we've sort of somewhat for, I think, historical reasons, we've done the June, July, August calls. So, that's like a 2 to 4 month. And maybe we should focus on something a little shorter that we would have better skill at. And I think that's part of the motivation for inviting the September outlook this year. I think this kind of, I think you could argue in both directions of focusing on a shorter timeline because, the June outlooks barely have any more skill than just a trend line. But then there's plenty of evidence that there should be skill at that lead time. Thickness anomalies, melt onset anomalies, all this talk about precondition in the sea ice. Why did Walt show the meteorology through the winter and spring? Because we believe that ends up having an impact on summer sea ice conditions. So these are all aspects that models, if you start a model forecasting on June 1st, you should be able to incorporate all that information, right? And there should be some skill in your forecast because you have that information of what's happened in the winter and the spring.
Hey, Ed, do we have an idea of how shorter term, week to week forecasts how the skill in that changes seasonally? The thing you just said about how, June versus September 2-week forecast.
There's only a couple papers looking at a kind of a very short-term skill in CI's forecasting, like the in the S2S models, for example, Zampieri, who I believe is a student of Thomas Young. There's a 2018-2019 paper. We had a postdoc look at this, and that paper's in review right now. But there's not much research on it. And so, yeah, there is some evidence that it does change seasonally. but there's also a lot of spread across models at that very short. So going back to not being too depressed about these results of skills, if you look at truly the sub-seasonal skill in these models that, they only run for 6 weeks, quite a few of those models really struggle also in their skill at the week 1, week 2 lead, so very short lead times. And they probably suffer from similar biases. But anyway, to answer your question, I don't know that we understand exactly yet how that seasonal skill changes. There's different mechanisms, right? So in the summer, you probably care about sea ice thickness, and in the winter, in the freeze up season, you care about SST anomalies to the south. So how good your forecast methodology is capturing that information will have an impact.
Thanks, everyone. It's at the 90-minute mark, and I want to invite everyone to stay on after we run our thank you slides and continue conversation as you want. But I do want to honor the half hour, and if folks are leaving, to say thank you very much for joining us today. And I want to thank Walt Meier, Edward Blanchard-Wrigglesworth, and Uma Bhatt for their great presentations, and especially all of you who participated today. There's very good discussion, and I think that was really useful. Today's webinar will, as I said, will be archived and available online, and we will send an email to everyone who registered when that's available. Please take a moment to share your input about today's event by taking the short evaluation survey at the link you see on your screen. And that link will also be available in the follow-up email that you receive. Thank you. Let's go back. So for those that are leaving at this point, we really appreciate you joining us. But I do want to leave the discussion open because it seems like there might still be good discussion going on. Thanks. So this is where we want to have continued just fun discussion if it's available.
So I'll ask a question. I thought that when we were talking about the anomaly forecasts, was it the trend over the whole period, or was it since like 2007?
Well, I looked that up yesterday too, and to see what language we used for the models, and I'm paraphrasing it, but I'm pretty sure we said, calculate the anomaly with respect to your trend line in your hindcast, however long that is. So we didn't specify a specific range. Now for the observed anomaly, yeah, you're right. I used the whole period, so you get 0.72 and you got 0.61, right? Yeah. So yeah, there's a little bit of uncertainty, depending on how you exactly do it in observations. But I don't think my results really, if I'd use 0.61,
it would be that different.
Yeah, like the kind of the take-home message is kind of the same.
Yeah, but I guess if we're making a contest of this, we need to be very clear. And I think we did it so everybody could respond to the anomaly, but just to see if we want to continue it.
Maybe can I put Mitch on the spot, because maybe he can update us, or if he's got any updates on that on the community study of kind of the retrospective skill. I don't know if he wants to comment. Or...
Yeah, absolutely, no problem, Ed. Yeah, so for everyone still on the call, we are planning, this kind of came out of the SIO Contributors Forum meeting back in January, and sort of piggybacking on a lot of the issues that Ed raised about trying to understand this huge spread in SIO forecasts and reconcile the fact that there's been a number of hindcast studies that have claimed that we have skill at, say, 1, 2, 3, 4 months lead time. And if we have skill at those lead times, that means we should have RMSEs less than the interannual standard deviation, which is around 0.6 million square kilometers, which is much less than the spread we get in the typical SIO ensemble. So kind of the motivation was trying to sort of reconcile those two those two pieces of information. And what kind of came out of the discussion at the contributors forum was to try to get groups that had longer term hindcasts available, defined as more than 20 years of hindcast data, to submit hindcasts and then do a very systematic sort of apples to apples comparison of skill, which would let us evaluate sort of what systems have skill and do sort of a proper comparison, which could then potentially underpin, the weights that Uma was describing earlier in sort of a weighted multi-model forecast, for example. So the update is we've developed a call for submissions, which we're kind of finalizing right now, and we're hoping to put that out sometime in the next month or so. And then we'll ask for anybody who has either dynamical, statistical, or mixed forecasts available that have at least 20 years of hindcast data to submit those to us, and then basically participate in the intercomparison study, which will involve sort of a quantification of skill and then trying to dig into the reasons for the differences in terms of model physics formulation, initial condition, error, data assimilation methods, observations used, all those different sources of predictability as well as sources of error, and trying to synthesize results to the degree possible amongst these different systems. So that's kind of the overall view, and we're still very much in the development phase. So if anybody is keen on being involved in the development, please let me know. And just in general, I really enjoy your contributions to the paper, and we'll be in touch if you're interested. And if there's any questions, I'm happy to talk more too.
Mitch, do you want to share your email contact in the chat?
No problem. Yeah, I'll add it in there right now.
Thanks. Same with you, Uma, for the people that are still on, because you invited folks to give you some feedback. William, did you want to say something?
Yes. So, Mitch, that's really great idea. So it's kind of like to what Mike just mentioned about the model in the comparison. And I was wondering, are you only collecting the sea ice, or are you the variables, or are you also collecting the atmospheric forcing variable? Because I'm suspicious that might be contribute to a lot of forecast uncertainties in the sea ice forecast.
Yeah.
So our plan is to request only sea ice variables, specifically a hierarchy of Pan-Arctic sea ice extent, regional sea ice extent, and then September sea ice concentration forecasts. So sort of a hierarchy of large scale to more grid point scale forecast evaluation. And then in terms of the atmosphere and ocean side of things, we are requesting just some metadata from different groups regarding what data sets they've used in terms of initializing forecasts and that sort of thing, but not requesting any actual fields from the forecasts. So we're hoping to consider those aspects, but we won't be sort of evaluating. Our main evaluation is going to be all sea ice fields, and specifically sea ice extent and concentration.
Right, but then thinking about what Mark Street mentioned this morning, it looks like the summer circulation really control the ice forecast. So I was wondering if you could collect at least maybe some temperature and the sea level pressure pattern, that probably can help you identify what's really the reason to make the ice forecast right or wrong, especially at sub-season scales.
I fully agree that that's a fascinating idea. I think we were hoping to kind of keep the call relatively minimal, and we thought that these 3 levels of data was already a bit of a burden on contributors, so we didn't want to go too far. And then additionally, a number of people who do, say, statistical forecasting may not even use atmospheric data, or they use different predictors, let's put it that way. And so we know for a fact that every single contributor does, produce a sea ice forecast, but only the dynamical models would produce, atmospheric fields, for example. So, and we wanted to really have part of this paper be a systematic comparison between the skill of machine learning, statistical methods, which, as Harry properly noted, are the same, of course, same category, and dynamical models, and try to answer the question, are are dynamical models better or worse than statistical models in general? My impression is that the statistical models have slightly higher skill in the hindcast papers that have been published, but it's hard to actually do a proper apples to apples comparison. And so a lot of the motivation for this is just to sort of put them on the same footing in a very clear and concise way. So I really agree with what you're saying about the atmospheric fields, but we thought it might be just a bit too broad potentially.
Mitch, what you said brought up another idea, a thought that occurred to me over the last kind of looking over the SIOs. Next year, do we make machine learning and statistical one category again? So we have statistical and dynamical. You know, if they're not really separate categories, maybe it's more confusing to keep them separate in the SIO.
I'd be tempted to put them together. Just I was like Harry, I was very mildly offended that machine learning got their own category, and because it seems like machine learning is being put on a bit of a platform. And I think it's very interesting, but I think the statistical methods are also fairly sophisticated, and I don't know. To me, I see them as a common grouping, but that's just my personal opinion.
Yeah, thanks. I think that was something that had struck us. So.
Well, we've gone 10 minutes over. It seems to me that discussion is closing down. So I want to thank you all again for joining us. And again, thank you to Walt Meier, Ed Blanchard-Wrigglesworth, and Uma Bhatt for some really good presentations, and especially to all of you participants today for engaging in rich discussion. It's been a very useful webinar. Stacy, can you share those slides again? Just on behalf of ARCIS and the SIPN team, we want to thank everyone for joining us today and remind you that today's presentation will be organized at arcis.org SIPN meetings webinars. And we'll notify everyone who has registered for the event that the archive is available when it is. And if you have an opportunity, please share your input on today's webinar via a short evaluation survey at this address, the surveymonkey.com/r/SIPN2. And with that, I think I'll say thank you to everybody for joining us and conclude today's webinar. This has been really great. Have a great day and good beginning of your week, and good Indigenous Peoples Day.